The next encryption mechanism incorporated by this hotspot is WPA. What is WPA and how is it different from WEP? WPA. WEP uses a 40-bit or 104-bit encryption key, which do not change and needs to be manually entered at the access points and clients. To overcome this weakness, WPA came into existence. WEP generates a per-packet key by concatenating the IV directly with the passphrase or master key, which exposes the master key to carry out attacks such as FMS and PTW attacks. WPA stands for Wi-Fi Protected Access, which works based on two mechanisms, namely PSK and TKIP. The PSK is a client authentication method wherein the network admin assigns a passphrase containing up to 133 characters. This passphrase is XOR-ed with keystream, which is a combination of a random 32-bit key, with IV, which is nothing but the checksum of 32-bit in length, to generate unique encryption keys. These encryption keys are constantly changed on a timely basis, which is then shared between the clients associated with the network. When a new client gets connected to the network, authentication request is sent to the access point, which in return sends a response asking for the password. A connection is established once the password is verified. PSK. Pre-shared key is simple and was designed for small offices and home networks that do not require an authentication server. However, the encryption keys tend to become old as time changes, since these keys are not generated dynamically upon login and are subjected to brute force and dictionary attacks. This paves a way to opt in for the second authentication mechanism, TKIP. Temporal Key Integrity Protocol enhances WPA by increasing the length of IV by adding an extra 32 bits to the original 24-bit, accounting to 56 bits, to generate a unique encryption key for each client. However, only 48 bits are used in practice because 1 byte must be thrown away to avoid weak keys. Supposing for the communication between two clients connected in a network, TKIP takes an extra precaution by ensuring that the data packet has not been altered or modified in any way by the attacker. If the data packet seems to be altered, it is dropped off. This is achieved by the 64-bit message integrity check, commonly known as the Michael algorithm. TKIP employs a per-packet key mechanism to dynamically generate a new 128-bit key for each incoming packet. This avoids the same keys staying in use as they do with WEP. TKIP also provides a rekeying mechanism in which it changes the encryption key of an ongoing communication in order to limit the amount of data encrypted with the same key.